All right, team, let's get back to work. So we're looking at lesson 5C, so please turn to page 49 in your physics booklet. Now, work's what we're going to talk about right here. So like displacement, velocity, and acceleration, our old friends, work can also be graphed. A work graph is represented as force versus displacement or position. So write that down in your notes right now, please. Page 49, that red stuff needs to go in your notes. Okay, let's continue on this learning journey. So here's what this force versus position graph might look like. Now, let's dig in deep. So just at the bottom of page 49, it tells us that just like acceleration versus time and velocity versus time graphs, work can be discovered by calculating the area under the line of the graph. It's like magic. We just need to figure out the area on the actual graph itself, and it'll give us that number we're looking for. So an example of the simple ways that we find this sort of area would be just the area of a rectangle equals length times width, which is equal to force times distance, which we now know is work. Area of a triangle is just half of that, which again, that force times that distance is work. Work. All right, page 50 now. So there's two ways we can solve for work using graphical analysis. So we can use fancy geometric shapes and get all mathy, or we can just get out our crayons and count those squares. But let's start fancy. All right, so solving work graphs using geometric shapes. So some will be easier to calculate from than others because they can be separated into those geometric shapes. And you'll see what I'm talking about here in just one second. So again, these common area calculations are in your notes, but we're just talking about that area of a rectangle, length times width, area of a triangle, half of the base times the height. And then getting all fancy for math class, we're talking about the area of a circle. So that can be pi times radius squared or pi r squared. If that's totally new to you, you haven't seen that in math class yet, don't stress about it at all, okay? Just it's in your notes, don't worry about it. Moving along then, still on page 50. So, wait a minute, but how on earth are we going to figure this out using math? Well, I guess we'll start at the beginning. Let's find a really simple geometric shape. How about a nice old square? Because we know how to figure that out. We're going to find the area of that by multiplying the length times the width. So the length would be 4 meters and the width would be 50 newtons. So we're going to multiply that together and that'll give us 60 joules, because if we remember, when we have an N and an M together, that is a joule in our fancy new scientific way of doing things. Okay, so we got part of the graph there already. We're doing pretty good. Let's move along. Now, this looks like a pretty good square. We know how to do that. Let's just do it again. It's easy. So we'll do the area of that square is equal to the length times the width, which again, we're talking about 4 meters here because the difference between 4 and 8 is 4 meters. That's the difference here. And we're going to multiply that by 10 newtons. So again, we have that'll multiply out to 40 Newton meters, or in our fancy new terms, joules, a big old J. All right, so what are we going to do next? I think this triangle will be the easiest one. And what we're going to do for that is the same thing, but we're going to half it. So just half of the base times the height. So half of 2 meters times 10 newtons will give us 10 Newton meters, or 10 joules. All right, now let's get creative, because this last little bit, how on earth are we going to figure that out? Because looking at it, it's not like exactly a circle. So I can't just do half of a circle. So I'm going to get super sciencey here and I'm going to guess. So I'm going to say that the area of one square, just looking at it, so I could say 2 meters times 5 newtons for this smallest square in the leftmost bottom corner. That would give me 10 joules. And I'm going to guess that Both of these squares combined, each of them is about half a square, so I'm going to say that equals 1 square. So I'm just going to call that 10 joules. Now, with that, I have all of these different numbers, and I just need to add them up. Boop! And there we go. We're talking about 60 joules plus 40 joules plus 10 joules plus 10 joules, and that'll give us a grand total of 120 joules, and we did it! All right, take a minute to copy this down, pause it if you need, and then we'll get out our crayons. Okay, I'm going to switch sides, so if you haven't copied it down, pause it right here. Here we go. Continuing on with page 50. So let's solve for work by counting the squares. So some force versus position graphs are more complicated to calculate work with because the shapes of the graph can't be separated into geometric shapes. Again, when we're saying geometric shapes, we're just talking squares, I don't know, triangle, circle. Let's call those what we care about here. Okay, so there is an order to doing it that I recommend. You can probably fake it and do just fine because we're counting squares, so whatever. But we'll just go with this formula here because it's the easy way to do. And as things get more complicated, if you have a series or a way to do things, it's a little easier, and that way you don't miss anything. So all we're gonna do is we're gonna start by calculating the area of one square on the graph. Then we're going to count the number of whole squares under the line on the graph. So we're just going to count the easy ones. Then we're going to estimate the number of remaining squares that are like right on the line that are harder to tell. And then we're just going to multiply the number of squares by the area that we calculated there at first. So let's just do an example, because why would I expect you to understand it by me just telling you these 4 steps that mean nothing to you? So let's put them into action. Let's look at this graph. Please consider this graph, friends. It's on page 51 now. So first thing we're going to do is we're going to calculate the area of one square. Boom. So area, length times width. If we look at our left bottommost corner, because that's just the easiest place to start, we have 2 times 5. So that tells us that there's 10 joules represented in each square. Okay, easy. All right, so now let's count the whole squares. 1, 2, 3, 4, 5, 6 squares. So I'm just going to put that down there. I know I got 6 full squares. Next, I'm going to estimate the remaining squares, which is a little tougher, so 4 seems like a good number. Let's go with 4. Boom. Okay, now we're just going to multiply that together. We're going to add those squares that we counted. There's 10 squares that we counted out, 6 whole squares plus my estimate of 4 squares. And we're going to multiply that by 10 joules per square because we know that's how much each square represents. And that gives us a big ol' 100 joules represented in this graph, 100 joules of work. All right, copy this down. I'll give you a few seconds and yeah. All right, pause it if you need more time to copy this down. Otherwise, let's celebrate. We just did it. We did it. Okay, so now please do this. Please do the practice questions on pages 51 to 53 of your notebook. Seems like a lot, but it's just a few big graphs. You got to do some counting and some mathing and try to make it fun. You're kind of like a detective now. You have all these skills and you're putting them into action. Just rock it. Okay, so do that and then go play outside. Good luck and happy sciencing.